In this video, we'll take a look at problem number 23 from out of section 2.1 in our textbooks. And this is a problem where we're asked to find an equation of the tangent line to this curve at this x value. Most of the work is going to require us to find the slope of the tangent line. We can't forget that we're asked for its equation. Okay, so in the end, this is going to just basically become an Algebra 1 question, but the calculus portion of this is to find the slope of that tangent line. And to find the slope of the tangent line, what we need to have is we need to have f prime of, we want to know the slope of the tangent line at -2. So we need to know f prime of -2 here. And we have to use our definition of the derivative to do this, and that's going to involve the limit as h approaches 0. And in the numerator, we're going to have f of. Now, if I was looking for the slope at several different values, I wouldn't want the -2 here. I'd want to leave an x here, and I'd want to leave an x here. But since we just want to know the slope at -2, we're just going to go ahead and put the -2 in place of the x's in that definition. That'd be minus f of -2, and this would be all over h. So what I want to do before I go ahead and try to evaluate a limit, I want to compute the first component of the numerator and the second component of the numerator before I get too wrapped up within the fraction and within the limit. So I'm going to compute f of -2 plus h first, and here's my function f. If I want to know f of -2 plus h, I just need to put -2 plus h in place of that x. So I'm going to be looking at the square root of -2 plus h going in place of x. Grouping symbols there aren't really doing anything for me other than just kind of showing that that's what I put in place of x. And then I'm going to have my plus 3 still underneath that root. There's a little bit of simplification you can do with this. You can go ahead and combine the -2 and the 3. And when you combine the -2 and the 3, you're looking at a plus 1. So f of -2 plus h would be square root of h plus 1. And if I wanted to compute f of -2, right, the other component within this numerator, that's a little bit simpler to do because I'm just putting -2 in place of the x in the function. And that's going to be square root of -2 plus 3 equals, well, I guess, square root of 1, which would be 1. So I have the two pieces that need to go into my numerator within this limit, and I'm just going to go ahead and toss them in at this point. So I'll be able to say that f prime of -2, excuse me, f prime of -2 is going to be found by taking the limit as h approaches 0 of f of -2 plus h. We have that right here in a simplified form. So I'm going to take the square root of h plus 1 and toss it into that formula, and then minus f of -2, which is right here, so minus 1. All over h. Now I told you that when we do this with a polynomial, you will always get something out here to cancel with something that you have here. In the case of this particular function, this function that has the square root, we're going to have to kind of go back into chapter 1 and think about some way to evaluate this limit that we used previously. Because if you put 0 here, square root of 1 is 1, minus 1, 0 in the top. And if you put 0 in place of this h, you get 0 over 0. We need something to be done algebraically here to get us past that indeterminate form. And in chapter 1, every single time we saw something like this pop up and it was within a limit and there were roots in the limit, we wanted to rationalize. So I'm going to use the conjugate of my numerator, and I'm going to multiply my numerator by that, and I'm also going to multiply my denominator by that. And if I go ahead and FOIL my numerators together, within this limit, I'm going to have h approaching 0 still. First times first, well, if I multiply this root times the same root, it's that root squared, and out comes the h plus 1. Outer times outer is going to be positive 1 of these roots. Inner times inner is going to be minus 1 of these roots. Those are going to cancel. And then last times last, -1 times positive 1 is going to be a minus 1. And this is all over h. Oops, almost forgot a big component of that denominator there. Let me get a little more room. I have h times all this stuff in my denominator. I could distribute the h into both pieces here. I'm not going to elect to do that, and you'll kind of see why in just a second. But what I'm going to do at this point is do this cancellation. So in that numerator, we definitely do get the plus 1 and the minus 1 to cancel. The reason why I wanted this denominator still to be written with multiplication is because if I would distribute here, I couldn't cancel this h with that h. But since this is multiplication, I can go ahead and cancel these h's. So now within this limit, I'm still having h approach 0, but my numerator, I don't have anything left, so I need a 1 just to kind of hold that spot. Then I have the square root of h plus 1 plus 1. Put 0 in place of the only h you have left. That's a square root of 1 right here. Square root of 1 is 1. So we have 1 over 1 plus 1, or 1/2. So we get 1/2 for f prime of 2. This tells us that the slope of our tangent line is equal to 1/2. Now I want to kind of think back to what I underlined in the set of directions earlier. We wanted to find the equation, or an equation, of the tangent line. So I'm going to have to do a little bit more work, because all I have right now is the slope of that tangent line. I'm going to go for this tangent line in slope-intercept form, so I want my answer to be in y equals mx plus b form. I know my m, so I have 1/2 that's going to go in place of the m, but I don't know what my y-intercept is. If you think about how this curve is going to be related to the tangent line, the curve itself, and you can confirm this by graphing on the calculator, the curve itself is going to look something like this. And it's at -2, we're going to have some line that hits the curve with a slope of positive 1/2. The point of tangency is guaranteed to be both on the curve and on the line. So we know the slope of our line, and if we can determine what that point of tangency is on the curve, we'll also know a point on the line. The x-coordinate of this point of tangency is -2. And check out what we did a little while back. We computed f of -2. We got a value of 1. So this ordered pair right there, the point of tangency, must be -2, 1. So my line has a slope of 1/2 and goes through the point -2, 1. I'm going to put the 1 in place of y. I'm going to put my m, slope of my tangent line, in place of m. I'm going to put -2 in place of x, and I'm just going to take a minute to solve this for b. And if I multiply these together, I'm looking at -1. And if I add 1 to that side, I'm looking at 2. And so the equation of my tangent line in slope-intercept form would look like this: y equals 1/2 x plus 2. Just based on my rough sketch of this function in the tangent line a little bit earlier, we can kind of come back up to it. You'd probably believe that this line that I sketched in for the tangent line has a slope of 1/2 and a y-intercept that's clearly positive, and 2 would probably be a pretty believable value for it if this point had coordinates -2, 1, which it does. If you wanted to graph these on the calculator, graph the function and the tangent line on the calculator, you should see a better version of what I tried to sketch right here a couple minutes ago. So this is how you can find the equation of a tangent line by using the definition of a derivative.